Ultra technology on unique combat ships. A new aircraft carrier for the fighter planes of the future. The latest submarines armed with nuclear missiles. Giants of the sea, designed and assembled by one and the same company.
Only one company in the world can produce all these types of ships, and that is Naval Group.
In huge factories spread all over France, Naval Group, which is majority owned by the state, builds the ships of the future. Some will enter service in around 15 years. Others are ready to set sail in a few months. Like the FDI, a defense and intervention frigate. Thanks to the extremely powerful sensors of its radar, it can detect an attack from dozens of kilometers away. Like the FDI, another ship has just come out of the shipyards. It's specialized in mine warfare. With its drones, it detects explosive devices in the water and destroys them using kamikaze robots.
The entire rear part of the ship consists of a huge hangar.
A gigantic parking deck for drones with state-of-the-art technology. They are due to be launched in 2035. France's third-generation nuclear submarines. On board, 16 ballistic missiles. Another major construction site, the successor to the Charles de Gaulle. The new supercarrier is due to enter service in 2038.
It will be the largest nuclear-powered surface vessel ever built in Europe.
For the first time, the French state and its highly secretive shipyards open their doors to us. Ships are equipped with nuclear missiles here. This makes the facilities a natural target for espionage and cyber attacks. Like in Cherbourg, where the submarines for France's deterrent force are being developed.
Permission to film on this site is something extraordinary. We rarely see cameras here. After all, the smallest object can reveal a lot to a trained eye.
From a photo of the wall thickness of a submarine, an expert can deduce its maximum diving depth. The design of a propeller blade can indicate the acoustic signature of the boat. So secrecy is the be-all and end-all as the future French Navy is invented in these hangars.
The entire range of our ships is manufactured here at Naval Group.
The reason can be found in France's past.
We are a young company, but we actually have 400 years of history behind us.
In the 17th century, Cardinal Richelieu, the first minister of King Louis XIII, decided that France must have a navy. An endeavor that required shipyards and correspondingly large basins, facilities that were soon among the most efficient in the world. Like the spectacular shipyard at Cherbourg. Coming in at 50 hectares, it's 11 times the size of a modern soccer stadium.
One of the largest construction sites of the 19th century.
Today, the company employs 17,000 people throughout France. In these high-tech cathedrals, 120-meter-long ships are built. Sheets several centimeters thick are bent, and 200-ton blocks are lifted. The first fully digitized frigate is currently being built in Lorient. It's a revolution in the naval world. Currently, France can deploy 8 FREM multi-mission frigates. 140-metre-long ships with a displacement of 6,000 tons. The new type, called FDI, is smaller, but has a technology that is unique.
It displaces 4,500 tons and is just over 120 meters long.
We will integrate sensors, electronics, software and weapons. The FDIs can operate against submarines, air and land targets, in short, carry out all kinds of missions.
The new ship can also be used as an escort to protect an aircraft carrier. The units of the FDI class are the new generation of multifunctional frigates. The type represents the entire know-how of its engineers. Well designed from A to Z.
We get the sheet metal on trucks. It's stored outside the workshop, and then our ships are built in here, where the processing of the sheet metal is done.
A car sheet is a maximum of 0.6 millimeters thick. In comparison, the 30 millimeters that are processed here are extraordinary. It takes thousands of hours to bend all the sheet metal for an FDI.
We work with a tolerance of 3 millimeters compared to the templates.
The templates are pieces of wood that serve as a reference for the curvatures. All checks are carried out by hand to ensure the correct degree of bending. It's a prerequisite to allow the ship to take on its actual shape. The carpenters have the task of fitting the sheets together perfectly.
As a rule, 5 millimeters must be left between the individual sheets so that the welders can work with the correct spacing.
5 millimeters between sheets that are up to 10 meters long. A remarkable achievement. Equally remarkable is what follows. Here at the Lorient site, an army of specialists is busy non-stop with the welding work. The assembly of the first parts of the hull is an extremely critical stage.
All our workers have been trained for our special welding processes. I have 93 welders on the job, which gives you an idea of the scope of the whole thing.
The first construction phases of the frigate require several weeks each. The workers pre-assemble entire segments of the future ship like pieces of a giant jigsaw puzzle.
We start working on the reinforcement, integrating pipelines, cable ducts and ventilation shafts.
In contrast to conventional ships, the lower part of the ship is absolutely watertight inside. The technology on board and the handling of the weapons require extensive equipment. Fitting out all these rooms is a complex stage that takes several months. Yet that's still twice as fast as a few years ago. It's made possible by the huge prefabrication halls. Entire ship sections come from here almost ready for operation. Kilometers of cables and pipes are already installed. It's one of the company's strengths, saving time by enabling the teams to work under optimal conditions.
This has revolutionized shipbuilding. Our predecessors assembled the ships sheet by sheet. We, however, work with hull sections weighing up to 300 tons, sometimes even more.
Prefabrication enables us to build ships in 36 months, which is a record.
The sections are assembled upside down in the workshops, which avoids contortion. The large number of workshops at the Lorient site is a considerable advantage. And when it comes to moving the ship's segments, gigantic overhead cranes are used. The parts to be moved weigh as much as 3 or 4 passenger airplanes. Maneuvering these metal giants is always a critical moment.
Each block, of which there are around 30 in an FDI, is inserted into the structure and welded together.
Thus, the hull is formed, 122 meters long, longer than a soccer field when it's assembled in the huge hall.
We have an extraordinary site here, 30,000 square meters in size. Actually, a covered basin where you can build 2 ships at the same time.
The frigate is gradually taking shape, a colossus on dry land. The 2 propellers are hidden, even from the numerous workers. 99% of the workforce know neither their shape, nor their size, nor the material used. A single photo will provide information about the type of the sound wave emitted by the ship.
The acoustic signature of the ship is strictly confidential. It's a state secret.
The propellers and their special rotation make the ship undetectable to the sensors of hostile sonar devices. But there is another possibility to locate a frigate from several kilometers away.
You can locate a ship by its heat signature, by its funnels.
Diesel engines are easy to detect because of the smoke they produce. The temperature rises to up to 1,000 degrees Celsius when the exhaust leaves the funnel. The solution found by the engineers, a cooling gas, added before the hot air reaches the outlet.
Thus, a warship like an FDI, which is 140 meters long, doesn't appear to be any bigger than a fishing boat.
Approaching a target by disguising yourself as something other than a warship is a technical feat. Even the operating noise of the 2 shafts turning the propellers is reduced to an absolute minimum. The key to avoiding even the slightest friction is the design of the shafts.
The interesting thing about the drive is the length of the shafts. They rotate over a length of 40 meters with a precision in the 1/10 of a millimeter range.
Adjusting the shafts is one of the last jobs in the hall. Then seawater is poured into the basin until the hull floats.
It's always an emotional moment. The launching, so to speak. We all stand on the quay to see the frigate glide into its future element for the first time.
But the new generation defense and intervention frigate is not quite finished yet. One of the most important parts is still missing. This marks the beginning of another spectacular stage, the assembly of the bridge, which is packed with technology.
It's the nerve center of the ship. This is where the operations and command center and all the ship's radar equipment are placed.
39 meters high and weighing 130 tons, the heart of the new frigate arrives at the quay. Completely prefabricated, it now merely has to be inserted into the deck of the ship. 30 people are busy operating an extraordinary crane.
The horizontal alignment and setting down of the bridge must be done to an accuracy of 3 millimeters. It takes about 2 hours to swing it into place. That's a long time and requires a lot of experience and extensive preparation.
Inside the bridge is one of the ship's groundbreaking innovations, a radar from the French company Thales. It's considerably more powerful than the systems on the old frigates. On conventional ships, it rotates on its own axis.
It's a fixed panoramic radar, as opposed to a radar that rotates. This allows a 360-degree view at all times.
Compared
to an old generation radar, which has a rotation frequency of 1 second per revolution, the new version makes it possible to react more quickly to a threat and fend off attacks.
To strike back even faster, the radar itself can automatically launch a missile. With anti-submarine torpedoes and Exocet missiles, the frigate is equipped for any attack on the high seas. Yet it can also defend itself against terrorists on elementary craft. Attacks that usually materialize in a sensitive environment.
C'est le genre de menace qu'on peut rencontrer quand on navigue à proximité des côtes.
It's the kind of threat you can face when you're on coasts with heavy shipping traffic, pleasure craft or the like.
Et c'est là que le danger est maximal.
It's difficult to distinguish whether it's just a person who is simply riding a jet ski for fun or a terrorist who is approaching with an explosive device.
D'un terroriste qui vient sur un jet ski avec une charge explosive.
To neutralize this threat, the frigate has conventional rapid-fire guns all around and sonic cannons. They emit an acoustic wave designed to disorientate the attacker, a frequency that can reach its target a kilometre away.
They are large loudspeakers that are directive, in contrast to a loudspeaker that simply broadcasts over a large area. The sonic cannon directs the sound in any specific direction.
There may be attacks from the air or on the surface, yet the danger can also come from the depths in the form of torpedoes. To detect and repel them as quickly as possible, the new frigate has an extremely powerful sonar in the bow.
Then there's a second sonar which is towed. It is lowered into the water and pulled by a cable.
Both the sensors of the towed sonar and those of the panoramic radar are processed by a computer system that is unique. 2 data centers take care of evaluating the thousands of pieces of information that the radars receive every second. They make the FDI the first frigate that is 100% digital. This means maximum efficiency, but also the risk of cyber attacks, a risk that the designers have taken into account from the outset.
It's the first ship that was planned as cyber by design. This means that cybersecurity was an integral part of the design, from the first phases of software design to production.
Every device is checked before being installed on board. The operating software is ship-specific and cannot be infiltrated from the outside. Cybersecurity is the be-all and end-all for all functions of the ship. Cybersecurity, as well as all other functions of the ship, will be tested over many months after the actual 3-year construction period has been completed. Then the new frigate will sail the oceans and fulfill its numerous missions. Missions for France, but also for other countries. For reasons of profitability, Naval Group exports its combat ships.
We sell within the framework of defense agreements, when the government has authorized us to do so.
The 3 frigates the Hellenic Navy has ordered from Naval Group can operate 300-kilogram helicopter drones. From the FDI-class frigates, these latest remote-controlled, high-tech flying machines can be deployed faster than ever. A definite trump card, since they are the future of naval warfare. Drones. More and more variants are being used for a wide variety of missions. And engineers have recently embarked on a revolutionary project. A world first in naval warfare. a ship designed solely for drones. Conceived and designed as a platform that is 100% intended for launching drones at sea, some resemble helicopters, others look like speedboats. There are underwater drones, and even kamikaze drones. An entire arsenal united on one carrier ship, with a single mission: to combat the threat of sea mines.
More than 80% of global trade is conducted via the seas, which means that whoever controls the seas also controls trade. And in a conflict, blocking the sea routes is a way of exercising power.
Mines are used for terrorist purposes, or to prevent ships from entering a certain area.
We are still clearing mines that were laid during the Second World War.
More than 500,000 mines were laid between 1939 and 1945. The threat posed by mines has been a concern for the French Navy for several decades. The previous method consisted of operating boats in the suspected minefields to clear the explosive devices. But the risk is considerable and the danger to the crews is great. The development of ever more sophisticated drones made it possible to develop a new strategy.
The ship no longer needs to enter a minefield. The aim is to approach the minefield and use autonomous technologies, that is, drones, to locate the mines and clear them.
This 82-metre-long mine hunter is smaller than an FDI frigate with its 120 metres. The crew is about 60 strong. Thanks to its design, it can deploy an armada of drones in record time. The basis for every mission is the hangar at the back of the ship.
The hangar has several elevators that can be used to bring all the equipment up or down.
Within a few minutes, the first drone appears and is launched to hunt for mines. It's to investigate a sensitive area.
Basically, they're small helicopters of 100 to 200 kilograms.
The remote-controlled helicopter is equipped with a radar, which alone weighs 10 kilograms. It was developed and manufactured by the French company Thales. The miniature helicopter can operate up to a range of 10 kilometers with an endurance of several hours, while drones for the mass market cannot stay in the air for more than half an hour. These technical marvels scan the surrounding surface with their radar and infrared sensors, just like the most modern French Rafale jets. There are two operators on the ship. One steers, the other analyzes the images. If the helicopter detects a suspicious object, another device takes over, an overwater drone. Its design resembles that of an outboard motorboat.
These boats are about 12 meters long and weigh 20 tons. They may not get you the best berth in a marina, but at least you'll be close by.
The mine countermeasure ship has two surface drones, which are housed in the large hangar. Their task is to get as close as possible to the mines and to identify the explosive device as precisely as possible. Yet, before they can fulfill their mission, they must be lowered into the water. A real challenge, as each weighs as much as a medium-sized truck.
They are swung out by a special mechanism and set down in the water.
However, the drone does not immediately come into contact with the sea. It's set down using a floating dock, a kind of bathtub that protects the drone from the first waves.
The tub plunges into the water, the drone goes into reverse and slowly leaves the dock.
The process only takes a few minutes. Yet lowering 20 tons onto the sea requires absolute mastery of the lifting equipment. The drone boat can move up to 20 kilometers away from the mothership to reach the mine-contaminated area. It pulls a sonar behind it in the form of a long rope to inspect the deeper areas. If a mine is detected, another device comes into play.
A robot that will destroy itself. Its task is to approach the mine, and when it is close enough, it can detonate the mine.
Costing only several thousand euros apiece, the kamikaze drones will be the most economical means of clearing large minefields, providing the French Navy with a unique capacity. The new mine hunters are to be delivered between 2025 and 2030. Just like the defense and intervention frigates, these ships are the result of several centuries of research and innovation. In terms of complexity, however, there is one ship where the bar is even higher. There is nothing like it in the world. France's newest nuclear-driven missile-carrying submarine.
It's the most complex product ever created by man.
SNLE-3G stands for third-generation nuclear submarine.
It's a missile launch base deep in the sea, with about 100 people on board, powered by a nuclear reactor. I think that makes it clear what kind of challenges you're dealing with here.
The SNLE-3G is a monster of power, and yet once submerged, almost undetectable. Never before have French engineers designed such an advanced submarine.
A Boeing consists of 100,000 individual parts, a nuclear submarine of 1 million. That shows how complex the whole thing is.
The most advanced technology in the world for a single mission, to prevent any other state from attacking France.
Deterrence is about signaling to foreign powers that threaten our vital interests that France has the ability to strike back using nuclear missiles.
A fearsome weapon that can be fired from anywhere. Thanks to its reactor, the submarine no longer needs to come to the surface. It generates its own oxygen even at a depth of 300 meters. The latest submarine is the product of half a century of technical know-how. In 1971, the first of its predecessors was launched, the Redoutable, a submarine carrying ballistic missiles that could be launched underwater. 16 missiles with a range of 3,000 kilometers. After launching, they soar into space and plummet onto their target at an unprecedented speed. The Redoutable is a colossus measuring 128 meters in length and displacing 9,000 tons. It makes France the 4th country in the world, alongside the USA, the Soviet Union, and Great Britain, to have submarine-launched nuclear weapons. It was conceived here in Cherbourg, in huge factory halls, with dimensions suitable for the production of the largest ships ever built in France. The most imposing is named after Maxime Laubeuf, a French engineer and pioneer of submarine construction.
It has room for a dozen triumphal arches, which is quite something.
The first diesel submarines were built here in 1899. The Redoutable marked the transition to nuclear propulsion. Since the end of the 19th century, 108 submarines have been built in these halls. The facilities in Cherbourg are second to none. They were expanded again and again to build ever larger submarines. Today, the designers are faced with a new challenge: to build a 150-metre-long submarine.
The state has presented us with a catalogue that specifies the intended performance of the ship and which is the basis for the design.
A design that will take a decade to implement. Work started in 2023, with the first ship expected to be delivered in 2035. The fourth and last boat of the third generation will be delivered in 2050. It will remain in service until the end of the 21st century.
The boat will still be in service in 2090 and be operated by our children and grandchildren. So it's a project that will outlive our own existence.
Building a submarine capable of firing ballistic missiles is a sequence of steps, each as crucial as the next. Starting with the first steel sheets arriving in Cherbourg, they form the hull of the submarine. It has to withstand the water pressure at depth.
The segments are several centimetres thick. For a surface ship, be it a frigate or a passenger ship, a few millimetres are enough.
Yet how can steel with such thicknesses be bent into a cylindrical curve? The answer is in a workshop in Cherbourg, and it's awesome.
It's a 12,000-ton press, one of the most powerful in Europe, designed for the second-generation boats, and also capable of forming the steel segments used for the new class.
The press can be adjusted with phenomenal precision to achieve the perfect rounding for a hull of 150 meters. Designing a sub is a quest for the optimal shape. The pressure at a depth of several hundred meters can attack the slightest imperfection in the hull's surface and crush the boat like a tin can. Once the steel sheets are bent and perfectly rounded, they're joined together to form hull segments. However, the new generation of SNLEs will benefit from an improvement in the joints compared to the previous submarines.
Whereas previously 4 segments were used to form the hull, there are only 3 on the SNLE 3G, even though it's a much larger submarine.
3 segments instead of 4, that's 1 joint less. A significant advantage, limiting the weaknesses in the hull of the submarine. It's therefore more resistant and can be subjected to even higher depth pressure. The reduction of the segments clears the way for another innovation on the hull. For the first time, a French submarine will have a second skin over the entire length of its body. The aim is to dampen internal noise as much as possible, but also to counteract hostile sonars.
We'll cover the entire hull with a kind of rubber that will muffle any noise that might come out of the submarine, allowing it to be quieter than its predecessors.
Silence is one of the keys to the mission of a submarine carrying nuclear weapons. To submerge without anyone knowing where the boat is. And thanks to its rubber scales, it will be even harder to locate acoustically than previous generations. The coating will also interfere with the sonar of enemy ships.
Active sonar emits a signal and detects an obstacle based on feedback, like radar.
The rubber tiles prevent the enemy sonar signals from bouncing back.
They absorb the wave of the active sonar that hits the boat, so it's not reflected and can't indicate the position of the boat to the enemy's tracking devices.
To be able to recognize threats, the SSBN-3G is itself equipped with new, extremely powerful sonar. The hydrophones, which are positioned directly on the hull, are designed in such a way that they can detect any noise at a distance of several kilometers. Yet the boat has additional ears that reach even further. Dozens of sonars are placed in a cable that is pulled behind the submarine. It's several hundred meters long. This allows the boat to extend its listening range enormously.
Under certain conditions, sound waves propagate in seawater over very long distances, sometimes several hundred kilometers.
The retractable sonar cable is a real innovation. The boat is driven by a giant propeller at the stern. Its design and the materials used are subject to absolute secrecy. There is not one single photo of this construction.
The propeller has a certain number of blades. It rotates at a certain number of revolutions per minute, and that generates the frequencies that can be identified by a sonar.
To limit the sound waves even further, the propeller is enclosed in a tube. This makes it possible to largely suppress the phenomenon of cavitation. Thousands of small bubbles that form as the propeller rotates create a telltale sound in the water. Recognizing a ship by its propulsion noise alone is an exceptional talent. The crew members who specialize in this are called golden ears. To outwit the enemy's golden ears, each part of the propulsion system is perfected as far as possible. The better tuned they are, the less play there is, and therefore less resonance and noise.
It's like a Swiss watch, only with us, the parts are several meters long.
The same perfection can be found in the workshops in Cherbourg or Lorient. They cut and operate at a level that is rarely found in the industrial world. Some machines are unique. Yet the part of the submarine that demands the most attention is here, the nuclear reactor. It was designed by the French company Technic Atome and is assembled in the workshops in Nantes. This is what enables the submarine to generate unlimited power. Enriched uranium, which boils water and releases steam to drive turbines. The nuclear reactor is the heart of the boat. Theoretically, the boat could remain at depth for several years. The reactor makes it possible to produce oxygen and drive the propeller virtually endlessly.
A nuclear submarine can remain submerged for years. In fact, its autonomy is only limited by its food supply, which is its biggest handicap.
Operating a nuclear power plant on land is already highly complex. In a submarine, on the open sea, with constant instability, it's even more so.
When the sub dives, the reactor compartment leans forward. When it rises again, it leans backwards, so the system has to be robust.
Yet, there's another problem in the section right next door. It holds the most destructive weapons, the latest M51 nuclear missiles. There are 16 of them aboard the third-generation SNLE. They are 12 meters high and weigh 50 tons each, about 15 tons more than the previous generation. They are fired underwater and are waterproof thanks to a gas envelope that protects them up to the surface. After launch, they reach space and then fall back towards their target at almost 20,000 kilometers per hour. Never before has France had such a powerful rocket.
You'd never do such a thing on land, place missiles right next to a reactor.
It's an immense challenge, operating the most sophisticated but also the most dangerous systems of all time right next to each other.
That's why we're forced to seal off these systems to make sure that a problem in the reactor doesn't spread to the missiles. The reactor room will be surrounded by a water hold. In other parts, radiation protection will be provided by lead, which absorbs the neutrons.
Tropical wood is also used. It's one of the most effective barriers, helping to protect the crew from radioactivity. The section with the nuclear reactor and the ballistic missiles is the most complicated part of a nuclear-powered submarine, especially when it needs to be maintained. How do you get parts weighing several tons out of the hull for repair? The other four world powers that also operate nuclear submarines had to find a solution to this problem as well.
When other navies need to carry out maintenance, the hull of the boat is cut in two halves by torches in a dry dock. The large parts are pulled out, repaired, and then the hull is welded back together.
Cutting a submarine in half and then reassembling it is a highly sensitive operation. It takes several weeks and puts enormous stress on the hull. If the process has to be repeated several times, the newly welded seams can become a risk. In order not to compromise the strength of the hull, a completely different approach was chosen in France.
We have developed so-called breeches, retractable doors through which we can remove all the material during maintenance work.
The design of the breeches above the reactor and the propulsion section are among the best-kept secrets of France's submarine builders. They're each several meters long and allow easy access to the interior of the hull. Their technology is as sophisticated as it is innovative.
You have to be able to open and close them easily during maintenance periods. And like the rest of the hull, they must be able to withstand the pressure. Even when they are closed, they represent a break in the hull, which must be watertight.
These openings are a considerable advantage in terms of restoring operational readiness. Nuclear deterrence requires that multiple SNLEs constantly patrol the oceans. With only 4 boats planned until 2050, France cannot spare any unit for too long. The USA, with its fleet of 14 nuclear weapon-carrying submarines, can afford to do so. Russia has 12 such units, and Great Britain 4. The third-generation SNLEs are the future showpieces of the French Navy. 1,000 people work on them every day, and 100 million man-hours will be spent on their completion over the next 30 years. Yet, in addition to the submarines, another supership is in the making. France is building the largest aircraft carrier in its history. A technical monster that will take more than 10 years to complete.
That may seem far. First launch in 2036, commissioning in 2038.
The new carrier will replace the Charles de Gaulle, which is due to be decommissioned in 2038. For the engineers and workers, this means maximum efficiency on a tight schedule. 75,000 tons displacement, almost twice as much as the Charles de Gaulle. 305 meters long, 80 meters wide, a completely redesigned Colossus. With a new catapult system to launch its SCAFs, the future combat air systems intended to replace the Rafale. With a crew of 2,000 sailors, the PANG, the new generation aircraft carrier, represents a project worth over 5 billion euros.
It's a city with an airport, 2 nuclear power plants, an ammunition bunker and a fuel depot.
The giant of the seas is largely designed and built here in Nantes-en-Dret. Yet first, proper conditions on land have to be created. Since everything has to be bigger for the new carrier, the halls have to be extended or even demolished to make room for new ones.
The Charles de Gaulle displaces 42,000 tons. We'll be at over 75,000. So we need more power, a new generation of reactors that meets this need.
That's not all. Just like the arrival of electric cars in our everyday lives, the new propulsion system represents a revolution for the French Navy. On the Charles de Gaulle, the nuclear boiler turns the two screws by driving them mechanically with steam. The future aircraft carrier will receive a radically new propulsion system. The steam is fed into turbines that convert this power into electricity, an energy that avoids all the problems of mechanical propulsion. It's a game changer in the use of aircraft carriers. The maintenance effort is drastically reduced. The ship will be ready for sea again in considerably less time, an essential aspect for naval strategists. Yet there is a second major innovation: the catapult system. To be able to take off from the short flight deck of the Charles de Gaulle, the Rafales are suspended from a sled on the deck surface.
Under the flight deck is a kind of syringe powered by steam. It pulls the landing gear of the airplanes to give them enough speed to take off.
50 cubic meters of steam forced into the system propel the sled over 75 meters.
That's an enormous force. It accelerates the aircraft in 3 seconds from 0 to around 250 kilometers per hour.
The catapult uses the steam from the nuclear reactors to achieve 80 tons of thrust, a force that is just as brutal for the pilots as it is for the mechanical parts, especially with launches every 45 seconds.
The more steam you apply, the hotter it gets. The more it expands, the more you have to control it to recalculate the pressures.
The time you need to do this today and the mechanical pauses that have to be observed will be greatly reduced with the new carrier. The steam that drives the carriage is no longer necessary. Instead, an electromagnetic system will be used. A kind of magnet will pull the aircraft.
We will be able to regulate the takeoff more finely, which means a less abrupt takeoff and less stress on the aircraft.
Smoother hardware means fewer failures and a higher takeoff rate. The 30 SCAFs, the fighters of the future, can take off one after the other in record time. The deflectors, on the other hand, will be the same as those on the Charles de Gaulle.
A deflector is a steel plate that is raised up behind the aircraft and ensures that when the plane is at full throttle before takeoff, the heat jet from the turbines does not blow backwards.
Deflectors are used to protect the ground crews behind the jets. The engine exhaust heats the deflectors to several hundred degrees Celsius. When they're lowered to bring the next aircraft to take off, this poses a problem. The deflectors are cooled to prevent the plane's tires from bursting. Thus, there's surfaces available again for aircraft that are waiting to take off or have just touched down. The second critical phase in carrier operations is when a jet returns from a mission.
You arrive at 250 kilometers per hour and touch down on a tennis court.
To stop a Rafale with an average weight of 15 tons, its brakes are not sufficient. Therefore, the pilot is supported by steel strands laid out on the flight deck. They're called arresting cables or wires. Using a hook at the rear of the aircraft, the pilot can catch one of the 3 cables, stretched across the deck at intervals of a few meters. The wires are essential for the pilot when landing. A flight deck that suddenly sways from side to side due to the swell can turn the landing into a disaster. Therefore, it's essential to anticipate the movement of the ship.
The Charles de Gaulle and the new carrier are equipped with a system that balances the heel so that the flight deck is always level, no matter what the sea state or what maneuvers the ship is making. It is a tension system with weights that are located under the flight deck and compensate for heeling by moving from starboard to port.
The automatic stabilization system called SATRAP is unique. It consists of 2 by 6 rows of steel weights that move on rails that run across the ship. They constitute a mass of 240 tons, enough to compensate for wave troughs of up to 6 meters. They react automatically according to the movements of the ship. Yet another factor contributes to the stability of the future supercarrier: its weight. Almost 75,000 tons of displacement, almost twice as much as the Charles de Gaulle, gives it enormous stability. It will only sway in very heavy seas. A clear advantage, even if France still lags behind the standards of the world's largest fleet. With a length of 333 meters and a displacement of 100,000 tons, the USS Gerald Ford is the Goliath of aircraft carriers. 70 combat aircraft and a crew of 4,500, and costing almost 15 billion euros. Yet France is still the only other country in the world operating nuclear-powered aircraft carriers. From the design offices to the carpenters, French shipbuilding will continue to deliver cutting-edge technology, meeting the many challenges that are emerging on the world's oceans. From access to extractable minerals, to securing data cables between continents, and monitoring maritime borders.
Mastering the oceans is a 3-dimensional task. There is the surface, but also the deep. These are extremely important areas for any nation that wants to preserve its sovereignty.
With more than 10 million square kilometers, France has the second largest sea area in the world. A resource that must be protected from countries who may be tempted to invade these regions. And so, engineers and designers will continue to develop the combat ships of tomorrow.